AP ladies, yeah, but Emma doesn't take AP nine. Emma's on.
And Mr. Klein, Emma wasn't here earlier.
Emma computer said, nobody said he's dead.
And Mr.
Okay, wait, respond. Guys, page 14, I just want us to finish number 8. We're just gonna do some more practice with log equations. And then we're just doing a review with these solving equations today, tomorrow, and Thursday. So number 8, we talked about how we can rearrange the equations in a way where we can take advantage of these log properties. Condensing. Once we get the two natural logs on the same side, we can use the quotient property. Natural log of A minus natural log of B is equal to natural log of A over B. Remember, natural log is log base E. And then if I get it into exponential form, then we have some more algebraic steps that we can take more easily. I can force that into a fraction, equaling the fraction, cross multiply. And then I'm just trying to figure out a way how to get x by itself. So rearrange the terms so that my x's are together, factor the x out, divide the parentheses over. And then I do want to have some idea of what decimal value that is. So enter that in the calculator, I get negative 4.988. But the issue is anytime we have log equation, we have to make sure that it does not cause any parentheses expression to produce a negative, because log of negative or natural log of negative does not exist. So in this case, if I plug negative 4 or negative 5, close to negative 5, back in for x, I'm not able to get both of these expressions to produce a positive value. So therefore, this problem has no solution. Okay, so page 15, we're just going to start with number 6, and then we're just going to look for opportunities to, if there's a chance that we can use log properties, we can use it. So if we see logs on both sides, we're trying to get it into one-to-one relationship so that we can remove the logs. Okay. Any questions with number 8? Yeah. Yes, that's yours is correct too, because if I multiply the top and the bottom by a negative, it'll come out to your version. So that works. Okay, so let's go to page 15, and let's start with number 6. Okay, we're just going to go down 6 through 12. Okay. All right, so number 6, you see log base 11 equals log base 11. So that's nice. Everything's log base 11, but we need a one-to-one relationship on both sides if we want the log base 11 to go away. So we need to work on this side of the equation, right? So we see log of A minus log of B. So I can do log of A over B. Once I take that, apply that property, I should be able to drop the log components and just solve for x. Log of A minus log of B equals log of A over B. Log base 11 equals log base 11. We could drop those out. So say 3x equals x plus 5 over 2, cross multiply. Solve for x, I get x equals 1. And we got to double check, right? I got to make sure that everything inside these log expressions are good to go. Doesn't cause any of the parentheses to produce a negative value, so we're good. Okay, number 7. Everything is natural log, that's nice, but we do have to clean up that left side. Merge those two terms into one natural log term. So product property. Natural log can be removed. We can just focus on the quadratic equation. But we need to make sure we bring everything over to one side, right? Get that 0 to show up, and then it's a factoring problem. Solve for x.
Sure.
Yes.
So the test will be having any problems where the quadratic isn't factorable?
No, it'll be factorable. Yeah, yeah. If I give you quadratic equation, it'll be factorable. Okay. Whenever you get, yeah, so any solutions that where you start off with a log or natural log, make sure that you are entering back into the equation to make sure that that there are no extraneous solutions. We don't have to worry about it if it's an exponential equation to begin with, but if it's a log equation to begin with, we do have to make sure that we check. So one side factor multiplies to be -18, adds it to be 7. I get -2 and 9. Solve for x, I get 2 and -9. 2 is okay with both those parentheses, but -9 causes an issue with both of them. But either case, if one parentheses causes an issue with the solution, then it's an extraneous solution. So if it works for one but not the other, it's not good enough. We have to remove it. It needs to work for every one of my equation. Yes,
So if you plug in a number and then in the parentheses it comes out to 0, would that be?
that's right. 0 or negative numbers are no good, right? So it's got to be the only thing that we can keep. If it causes your parentheses to produce a positive number, that's the only case we keep it. You're right. 0 is undefined. Negative is also undefined. Okay, number 8. Okay, product property to get that left side in a condensed form. Drop the natural log. And then we can just focus on the factoring portion. Okay, number 9, whenever you're ready. Everybody good with 8? Oh, sorry. This, we can go one step further, my bad. So anytime that there's a GCF, it's not gonna, may not quite work. Or it'll be a lot easier once you take that GCF out. So if there's GCF possible, back to that GCF out. Both sides to be -6, that's it to be -1, a lot easier to find. The 3 is just a coefficient. There's no variable with it, so it just goes away. It's not going to produce a solution. So the issue is that 3/2 and -1 are both going to cause issues. So we have no solution here, but both of the candidates are extraneous.
What if we didn't factor out the 3 and we like kept going that way? I thought 9 is the solution.
It could still work. Let's see. Yeah, it can still work. Yeah, it'll still work. It'll just be a little bit messier.
I didn't get those numbers though with doing that process.
Oh, yeah. Let's see. Not 9 and 6.
I think you use -9.
And so
Yeah.
this reduces to be x minus 3/2.
Oh, I forgot to divide it back. Okay, yeah, thank you.
What decides if they're extraneous or not?
I'm sorry.
What does, like, what?
Okay, so what determines whether it's extraneous? So the big picture is that I can't have natural log of a negative value. So if it causes my parentheses to produce a negative value, then it's not part of the domain. So if I insert 3/2 in for x, I get 3/2 minus 3, which is negative. Natural log of a negative value doesn't exist. And same thing here. If I plug -1 in, -1 in for x, I get natural log of -4. So these points are not part of my domain, so it's not part of the solution. Yeah. Okay, number 10. Okay, there's a little bit of trickiness here. We do want to do quotient property, but what's getting in the way right now? What's not allowing us to clearly see? Yeah, that 2 is not quite ready for us to do it, so we do need to bring that 2 up. Now, when that 2 comes up, make sure that 2 is impacting the entire expression. So everything needs to be squared within that 3x squared, not just the x squared. So it's not 3x to the 4th, it's 3x squared quantity squared
So it ends up being 9x to the fourth. Now you're ready to apply those quotient property. This requires a bit more work here. I have to FOIL all this out. I cross multiply, FOIL all it out, bring it all over to one side. The factoring here, it's a little bit higher degree, but it's still doable. Multiplies to be -4, adds it to be 3. And instead of x and x, we have x squared and x squared. X squared plus 4 is not going to give you anything because if I do x squared plus 4 equal to 0, I get x squared equals -4. I can't take a square root of a negative number. It's not a real number. So we don't have to worry about the x squared minus 1 side. So if I plug in, solve for x, I get 1 and -1. And both of these are fine. Both -1 and 1. The -1 is protected by the x squared. So it is part of our domain. So nothing from the x squared plus 4, but we are getting 2 solutions from the x squared minus 1. Okay, 11 and 12. Okay, I do want to take advantage of my log properties, but I do want them on the same side. I mean, it'll be easiest if that one was sitting there, I can just remove the both logs, but that one is part of my equation, so I need to look to see if I can at least put the 2 logs together, so I can make them go on the same side of the equation. And they go from there. Okay, quotient property. Log base 10. In this case, we are going to get it into exponential form so that we can get this x easier to work with here. So once in exponential form, then I'll cross multiply and try to get x by itself. Two over 17 works, doesn't cause any issues with either parentheses, so we have a valid solution. Okay, number 12. Same idea, get the logs on the same side. Get the 2 on the other side. Ten point oh six is also review. I just want us to do a couple more so we don't forget about the previous section that we learned. So on page 17, can we just do those 6 problems, 10 through 15? Review some of the exponential equations. So page 17, we'll do 10 through 15. I'll go through each of them as well. Okay. If that's not enough room, you can feel free to grab a spreadsheet sheet that I have up here. Yeah, 10 through 17 on page 17. Sorry, 10 through 15 on page 17. Has the same idea as before. Double check, sticks works with both of my parentheses, so that's valid. Okay, everybody good with 10? Now 11, we could take the log of both sides, but I think there's gonna be a nice relationship here between 27 and 9. We should be able to bring them back down to share the same base, right? What base can we? Yeah, so we can have them both share base 3. Not every equation is going to allow you to do that, but if you see that relationship, it's going to be easier and faster to do it that way, even though you could get away with taking log of both sides and getting the answer still. But here, you can quickly just get rid of the base. Once you get that 27 as 3 cubed, once you get that 9 as 3 squared, the 3 can remove itself, and then just focus your portion on solving for x. Now, when you're solving an exponential equation, you don't have to double check your answer. Whatever answer you get, that's fine. It's only with log equations that we have to worry about, okay, is there going to be an extraneous solution or not? 12 is nice. You can just jump directly into exponential form. And just free that x minus 6 up to. Once it's an exponential form. (13) same way. Once you get that log base e showing that base, you can just quickly get it into exponential form. And then just focus on figuring out how to solve for x. For 13, I do need to double check. 5/2 is not going to cause any issue. 2.5 times 2 is 5. 5 minus 4 is 1. We're good there. Okay, 2 more, 14 and 15. Okay, 14, do you recognize what we need to do there? Yeah, making a quadratic equation. And then factor that quadratic equation, and you can bring back your e to the x. Okay, recognize that as e to the x squared minus 5e to the x plus 6. Create an easier version of the factoring problem. Bring back your e to the x. Sorry, I worked it out a different way here. I could definitely do this way as well. No need to double check with your original equation because it's not a log equation. Exponential equations are fine. Okay, finally, number 15. Property cube of 14. Okay, 15 is nice. Just get it directly into exponential form and solve for x. Double check that your solution is valid.
reason we use not log with two, three, or just show you?
Yeah, I just want to show the different variation of it. We get everything back in terms of log 3 over log E is same thing as natural log E. But you can just need to stay with what we can do. I'll talk about change of base later if something too, but yeah. Okay, so we're just gonna stick with this topic tomorrow and Thursday as well. So what you guys just picked up is the key for tomorrow's worksheet. I'm not gonna be here tomorrow because I have to proctor the AP Bio exam. So tomorrow, you guys will work on 10.07 review. Problems 1 through 31, but you'll just do the odds, AJ 21, and then on Thursday, we'll do the evens. But I'll be checking for classwork grade beginning of class Thursday. But you know, it should only take you half class, if not less, to finish those problems tomorrow in class. Okay. All right, come get your phones.
It's only 17.
Today.